I'm not ashamed to own my Lord, nor to defend his cause. Maintain the honors of his word, the glory of his cross.
And as was mentioned, our topic in this hour is going to be DNA and mutation. And as we've been doing along the way, we've been starting with some quotes, and so we'll do that again this morning. And our first quote comes from Bill Gates. Now, he is the founder of Microsoft. He deals with computer software and so forth. He's not a biologist or a chemist, not an anthropologist, or any of those science-related things. But he does know something about design and complexity of design. And so Bill Gates says biological information is the most important information we can discover because over the next several decades it will revolutionize medicine and lead to treatment for most diseases. Human DNA is like a computer program, but far, far more advanced than any software we've ever created. That's a good acknowledgement. Again, it's not coming from somebody who is a biologist, who necessarily understands all the ins and outs of DNA. But he's correct. He likens DNA to a computer code, but it's just so much more beyond what his company or any of his competitors have ever put out. They just simply cannot match the complexity. Richard Dawkins agrees with Bill Gates. He says the genetic code is not a binary code as in computers, nor an 8-level code as in some telephone systems, but a quaternary code with 4 symbols. The machine code of the genes is uncannily computer-like. Apart from the differences in jargon, the pages of a molecular biology journal might be interchanged with those of a computer engineering journal. So, uncannily computer-like, but of course more complex. Computer systems are binary. There's zeros and ones, and that's all that you've got is zeros and ones, just 2 digits. There's 4 digits inside of DNA. Those digits are A, G, C, and T. And so the binary code certainly required a designer, Bill Gates, and those who are working with him. They've got a bunch of intelligent people who are working together in order to make that software. Well, the DNA, which is far more complex, surely needs a designer. Now, I like his last statement here. Apart from the difference in jargon, you can basically interchange these 2 journals, the molecular biology journal and the computer engineering journal. There's one huge exception to that. You won't find computer engineers claiming that the computer code was the result of random mutation. They just don't do that. They understand that very, very brilliant people have devised this software, and so inside your computer engineering journals, they acknowledge those who have done the work. The evolutionist is not willing to acknowledge the one who has done the work. They're not willing to acknowledge God. Francis Crick, again, a biologist, co-founder of Molecular Structure of DNA. We had a quote from him yesterday. He says, an honest man armed with the knowledge available to us now could only state that in some sense, the origin of life appears at the moment to be almost a miracle. So many are the conditions which would have had to have been satisfied to get it going. This was written about 20 years after the discovery of the structure of DNA. And the evidence should lead one to believe that the existence of all things is a miracle. That we need to have some large explanation, some adequate explanation, which of course would be God. Anthony Flew, this was an interview that he had with Craig Hadson who was the editor of the publication Philosophia Christi. Anthony Flew at one time, and the man interviewing him actually had referred to him as a legendary British philosopher and atheist. That was once his perspective on things. He was an atheist. But notice here in an interview that he had with him, it says, "It now seems to me," this is Flew speaking, "that the findings of more than 50 years of DNA research have provided materials for a new and enormously powerful argument to design." Anthony Flew went from this legendary British philosopher and atheist to being a theist. He never got to the point, from what I understand, of believing that the Bible was God's word. But he came to the point of believing there had to be a God in order to create all these things. That the evidence and DNA seems to have been the turning point for him. And in fact, in the interview, he goes on to say that he had to go where the evidence led. And the evidence didn't lead to evolution. It led to a creator. So DNA is what we're going to spend some of our time talking about this morning. DNA is an information system. It's the information system of life. And all the quotes that we began with, they acknowledge that that's the case, that it is this information system. And the thing about information is, information comes by way of intelligence. It doesn't come by way of random chance. Matter itself does not have the ability to create information. Information must be put into place in that matter by an intelligent source. And so let's use Mount Rushmore as an illustration. Isn't it amazing how this rock in Keystone, South Dakota, randomly formed to show the faces of George Washington, Thomas Jefferson, Theodore Roosevelt, and Abraham Lincoln over who knows how much time, right? How much time would it take for rocks to do that through random mutation? That's not what happened, and nobody thinks that's what happened. This was the product of somebody designing it and several men working it. Over 400 men worked over a period of 14 years in order to carve this into Mount Rushmore. There's no way that ever could have just randomly happened over, throw however much time you want to at it. It's just not randomly going to happen because we see design in this. Again, how much more complex is DNA, the design of life? And how much more do we need to acknowledge that there has to be a designer for that? Think about books and newspapers, paintings, computers, vehicles, all those things. We're surrounded every day by things that show design. Everything screams out that it has a designer, and there's all kinds of factories out there, and we know that that's where those things are being produced. And yet the evolutionist vehemently says that DNA, which is the most complex design out there, is the product of random chance. It simply doesn't make sense. This is a DNA sequence. I didn't make that up. I went to bioinformatic.org's random DNA sequence manipulation suite and asked for a sequence of DNA structure. And so this is what was generated for me. Now, obviously it must be random, right? It looks pretty random to me. I don't follow any kind of logic or code inside of that. If you do, go ahead and point it out to me. It has the appearance of being random. And, well, that's what the evolutionary theory is all about, is things being random. And so, see, it fits. It fits the random nature of what evolution says. But it's not random. The problem is you and I don't understand how to read DNA. When we see that, we see a bunch of letters, and we don't know what those letters mean. But if we knew how to decipher it, then it would make sense to us. We'd be able to read it and understand what each part of that is dealing with. Because we don't read DNA, it doesn't make any sense to us. Here's what's happening, and not, that sequence is way too small for this, but we can liken our genetic makeup to a book. And so our genetic code is basically a series of letters like what we see on the screen here that make up words. The words are otherwise known as exons. Those words or exons, they're gathered together in what we would call sentences, or what are referred to as genes when we're talking about DNA. And those sentences or those genes, well, they're written on chapters which would be identified as the chromosomes. And so basically that's how the book of our life or our genetic code is structured together. Just because we don't know how to read it doesn't make it random. It's no more random than a book that is put together. We understand that for an author to put a book together, they need to structure the letters in a certain way to make words. And if they don't do it right, then it's not going to make words. And if they don't put the words together right in order to make sentences, then it's not going to make sense either. And the same thing on to the paragraphs and so forth. And so it's not a matter of things being random. It most certainly is not random. It is the order that needs to be. Anyone know what that is?
Binary code.
That's binary code. Can anyone read binary code? Just look at it and know what that says? So that might just be a random collection of zeros and ones, right? But it's not. If we took those zeros and ones and we plugged that into a binary to text converter, we'd end up with today's date. That's how you write September 29th, 2019 in binary code. But if we just leave it like that, it looks like it's just a bunch of random zeros and ones. We don't read binary code. And so, but the inability to read something doesn't make it random. It just means we don't understand the language. And so, September 29, 2019. Just a bunch of random dots, right? That's Braille. Now, somebody who reads Braille, if they're blind, they wouldn't be able to read that. They wouldn't be able to run their fingers over top of it. But that's Braille. Unless you can read Braille, it just looks like random dots. But let's translate it into something we can read. And it says it's been good to be with the East End Church of Christ this weekend. Just because we don't understand what we're looking at does not make it random. And the same is true when it comes to DNA, which again is so much more complex. A foreign language, we might look at a foreign language and it may look like gobbledygook to us. That doesn't mean it's gobbledygook. That means you and I don't know how to read it. And the same again is true with regard to DNA. Now, DNA, of course, again, we've said it's more complex. Each cell in your body has this complex coding sequence of somewhere in the neighborhood of 3 billion letters long. That's really long. Francis Collins has written in his book, The Language of God, a live reading of that code at a rate of 3 letters per second would take 31 years, even if reading continued day and night. That's how long the code is in each cell in our body. You and I are 99.9% alike so far as our DNA structure. 99.9%. That's what makes us human. Now, evolutionary scientists, they were excited to find that chimpanzees are 96% alike with you and I, with humans. 96%. And so they cite that as proof of evolution, because there's a 96% similarity between humans and chimpanzees. Well, we also share a 90% identical DNA with cats. And we share an 85% identical DNA with mice, 80% identical DNA with cattle, 61% identical DNA with fruit flies, And did you know that you are 60% identical to a banana? Does that mean I've got a distant cousin who's a banana? No, of course not. No more than I have a distant cousin who is a chimpanzee. But think about it this way. DNA are the building blocks of life. It shouldn't surprise us that all living organisms share common elements, because that's what DNA is. It's the common building blocks of life. And so the percentages are neither here nor there. To be human, to be us, is 99.9%. Anything different, we're not bananas, we're not descended from bananas, we don't have a common ancestor with bananas, nor do we have any of that with chimpanzees. The similarities, those are the building blocks of life again. So you and I are 99.9% identical. That means 0.1% is what makes us unique. And so the distinctions in genetic traits, like different hair colors, different eye colors, different skin colors, skull shapes, and so forth, that's what makes us unique. But again, even that is not random. That's based upon our parents. That follows through in our lineage. And so there's nothing random taking place in here. All right, well, let's talk about mutation then. Changes to information rarely work out well. I ran a simple 20-character, 4-word question through a random letter sequencer online. Just change it up and see, okay, what does it say? Can anyone make sense of that? You know what the question is? No one, eh? Okay. It shouldn't be that hard. It's only 20 characters, and 20 characters put in a random order, it should work out, right? All right, well, here's what the question is. Do random changes work? Apparently not. That was a very simple random change. Imagine if we're dealing with something that has, let's say, 3 billion characters in it, and we just toss those up in the air and see what comes down. It's not going to work. Mutation does not work. It doesn't work on the small things. It certainly won't work on the large things. Imagine what would happen if we do that with an entire book. Are you going to read the book? It is gobbledygook at that point. It makes no sense, and we're not going to read it. Any computer programmers among us, or folks who do maybe HTML for websites, that kind of thing? The websites that I currently take care of, I use WordPress now. It's just so much easier. It's sort of a drag and drop and you're done. But when I first started doing websites, I used HTML coding. And the thing about HTML coding, and I learned this the hard way multiple times, a single character missing or a single character in the wrong spot can really mess up your website. It can take it from going to that beautiful website that you anticipated to being, everything is just in a small column right down the side and it's illegible. Just one character out of place can do that. Random changes just simply don't work. That's consistently what the evidence says to us. Whether we're talking about websites, whether we're talking about languages, whether we're talking about DNA, it just simply does not help. It won't work. But the idea of intelligent design is despised by the evolutionary scientists. They don't want to consider it. They want us to believe random chance and random change happened over millions of years, and that's how all the life forms we have today came into being. The fact is, random change and mutation don't improve design, they destroy design, they muddle it. Carl Sagan, in his book Cosmos, he sought to explain how mutation works in the evolutionary theory. This is what he wrote. He said, "The secrets of evolution are death and time. the deaths of enormous numbers of life forms that were imperfectly adapted to the environment, and time for a long succession of small mutations. As I said yesterday, I believe it was, you can throw as much time as you want to at it. It still won't work because of the random nature of it. It just won't work. Random mutations do not result in things that are beneficial so far as the change of information. Dr. Cecil Martin, he wrote an article in American Scientist entitled A Non-Geneticist Look at Evolution. In it, he says this: mutations are more than just sudden changes in heredity. They also affect viability, and to the best of our knowledge, invariably affect it adversely. It just doesn't work. Mutations affect viability. Mutants generally die, or at the very least are sterile. And so you mix a horse and a donkey together, and what you get is a mule, and the mule is sterile. You can't do anything. And that's the nature of mutation. There's no evidence that has ever been shown where mutations have been productive, where they've actually brought about good. Sewell Wright, who is a geneticist, he wrote, "The one systematic effect of mutation seems to be a tendency towards degeneration." Things go the wrong way. They go towards destruction, not evolution. In 1988, biologist Richard Lenski began an experiment to demonstrate evolution over a vast number of generations. What he did is he started with 12 flasks, and he put E. coli in each of those 12 flasks, and carefully measured out a glucose solution to put in there for food. And there was also a high concentration of citrate, which is a molecular cousin to glucose. But the citrate was put in there in order to push the bacteria to evolve. You see, E. coli cannot metabolize citrate in an oxygen setting. And so he was trying to push them, okay, let's see if we can get it so that they will metabolize it. And so every day for over 30 years, technicians at Lenski's lab would transfer small samples out of those flasks into new flasks. And essentially what they're doing is they're separating out generations. And so in their material, they would say that they have somewhere in the neighborhood of 70,000 generations of E. coli. Now, the generation of E. coli, when it's in the human gut, if you've got E. coli in your intestines, basically it will produce a new generation about every 12 to 24 hours. And so that's why they were doing this on a daily basis. They would take a new culture from it every 24 hours. And what they have told us is, based upon that duplication rate, these 70,000 generations would be representative of approximately 1 million years of human evolution. So you and I, we don't reproduce every 24 hours. It takes much longer for a human generation. And so that's why I use E. coli, because the generation is so much quicker. And so what we should see then is evolution taking place inside of those many generations that are there. As impressive as that sounds, and we'll get to the results in just a bit, but as impressive as that sounds, their numbers are actually skewed. Because these E. coli were not in the human gut. They weren't inside the intestines. They were sitting in a flask or a petri dish. And according to Toddar's online textbook of bacteriology, yes, the E. coli generation is 12 to 24 hours inside the intestinal tract. But if it's in a laboratory setting, it's much quicker. It's actually 15 to 20 minutes. if it's sitting in a flask and not inside your intestine dealing with all the things that are in there. 15 to 20 minutes. Well, that means that over a period of 30 years, instead of there being 70,000 generations of E. coli, there was actually more like 788,500 generations of E. coli. And they just happened to take a sample out of, wide-ranging timeline inside of these E. coli. Well, that ought to be helpful, right? We've got more generations, more opportunity for evolution to take place. In fact, this 788,500 generations of E. coli would be representative of 11 million years of human evolution. Well, this is good. We're getting to see even more, right? Uh-oh. Do you know how long evolutionary scientists say it took humans to evolve? It was not 11 million years. Somewhere between 5.5 and 7 million years. This doesn't fit inside of their theory. This is actually too many generations. And so, what should happen, they should have huge, enormous changes, such that we're not even acknowledging them as E. coli anymore. All right, well, what happened? What did Lenski's lab find? They did find measurable growth rates in the early generations of the E. coli, but then reported that growth eventually slowed down somewhere between generations 40,000 and 50,000. So they grew a bit. And so Lenski, because he saw the growth, here's what he said: this is a beautiful example of adaptation by natural selection. But they're still E. coli. They haven't changed. They're bigger. They've grown larger. But they're still E. coli. They haven't changed into something else. One flask group. Again, he's got 12 different flasks. One flask group, flask number 9, somewhere in the neighborhood of generation 30,000 in the experiment, became cloudy and darker than the other 11 flasks. All the rest of them still look the same. Flask number 9, things are getting really dark inside that one. And so Lenski reported that the bacteria seem to have evolved the capacity to exploit citrate. Basically, flask number 9 is now able to metabolize citrate. And this is what he was pushing towards. This is what he wanted to see. And so he went so far as to say this: I would argue that citrate users are becoming a new species. So he created a new species. Hang on, they're still E. coli. They're not something different. They're still E. coli. In 2016, Dustin Van Hofwegen, he's an infectious disease expert with a PhD in molecular biology from the University of Idaho. He stated this. He said, "We conclude that the rarity of Lenski's long-term evolution experiment mutant, so flask number 9, was an artifact of experimental conditions and not a unique evolutionary event. No new genetic information evolved." Sorry, it actually wasn't evolution. As much as Lenski would say, hey, this is evolution, it's something new, it's becoming a new species, Hofwegen says, no, that's not actually what happened. Well, what did happen in flask number 9? Because obviously it was different. Everything else is the same, and flask number 9 is cloudy and dark, and something has happened. It didn't evolve. It didn't innovate or engineer some new kind of genetic code that enabled it to metabolize citrate. E. coli already had the capacity to metabolize citrate. It just simply could not do so in an oxygen environment. And so there was a repressor gene which prevented it from being able to do so. And so essentially what happened in flash number 9 was that repressor gene broke down. It stopped working. And so it's not a matter of evolution. It's not a matter of new genetic code. It's not a matter of it somehow, improving itself in order to do something. It's a matter of genetic code that was already present failing. That's not evolution. And yet that's what happened in flash number 9. The bottom line is this. Whether it's flash 9 or flash 1 through 12, whether it's 70,000 generations or 788,500 generations, they're still E. coli. They did not evolve. They started out as E. coli. They continue to be E. coli. My understanding is the experiment is still ongoing, though there's no reason to do that. It failed. But there is no significant change and no evidence of evolution. And so Lenski's experiment, again, it was designed to show that evolution takes place over a large number of generations and that we're going to see these mutations and changes and so forth, and it fell flat on its face. Friends, DNA is immensely complex. And the genetic sequencing is anything but random. The code is the way that it is so that we are the way that we are. If we start meddling with the code, then, changes will happen, but not for good. Random changes to DNA is simply not a viable explanation for human life or otherwise, for any kind of life. Mutation destroys and breaks down. It does not build.
I'm not ashamed.